Hey guys, this video for section 1.4. This one should be an easy one. It's perimeter and area in the coordinate plane. So we've been doing perimeter and area for a long time now, probably way back in elementary school, I'm sure. So hopefully this section will be a breeze for you. So let's do a quick reminder of some things. So just remember the perimeter is the continuous line forming the exterior or outside of a closed geometric figure. Okay. Area then, remember we're in square units. And area is the amount of two-dimensional surface. So like a piece of paper would be area because you have left and right and up and down. Something that might be a little bit different or unknown, and we'll do some examples here to make it make a little more sense, is concave and convex polygons. Now, concave polygons is a polygon, or a concave polygon is a polygon with at least one angle greater than 180 degrees, and these are interior angles. And then convex, all angles are less than 180. Now, 90% of what we do, or 99 probably, is convex polygons. So most of what we do is convex polygons, but you do need to know the difference. All right, so in example number 1, classify each polygon by the number of sides and then tell whether it's convex or concave. All right, so let's do both by the number of sides. So on A, here's 1, 2, 3, 4 angles, so there's also 4 sides. So that would be a quadrilateral. Guys, that's probably misspelled, but that's okay. I'm a math teacher. And then this one over here has 1, 2, 3, 4, 5, 6. So think back. What is a 6-sided polygon named? It is a hexagon. Okay, now we need to say whether it's concave or convex. Let's back up a little bit, guys. So notice how I numbered all these angles. You're going to make a lot less mistakes if you do that. Okay, trust me. People double count angles. People forget where they started, so therefore they don't stop in the right spot. If you number them, you're not going to make any mistakes. All right, now remember, a concave polygon has one interior that's greater than 180. So let's look at this one. This angle here, this would be 180, right? If we started here and went to here, that would be 180. We're going beyond that line and over. So this angle right here is greater than 180 degrees. And so therefore this would be an example of a concave quadrilateral. So that's what we would say. This is a concave quadrilateral. One of the ways I like to think of it is this angle here that's over 180. It almost makes the figure look like it's, let me get some red here, it's caving in right here. Right? If it's caving in, it's concave. All right, let's go to this one here. Well, none of these are bigger than 180. They're obtuse, but they're not bigger than 180. So this here would then be a convex hexagon. So if I asked you this on a test, you'd give me concave quadrilateral, convex hexagon. That's all you need to do. All right, guys. This is just a visual of the reminders of how you find the perimeter and area of triangles, squares, and rectangles. Like I said, you've been doing this for several years, so this is something you should know. These are things that I expect you to know for a test on your own. So I'm guessing the only thing that maybe you might have a problem with is knowing the area of a triangle. So area of a triangle is 1/2 base times height. Some people know it as area equals base times height divided by 2. Those are the same things. So if you know it as base times height divided by 2, you're fine there too. All right, let's look at example 2. It says find the perimeter and the area So we're going to find two different things of triangle ABC with vertices -2, 3. So guys, let's plot this. It gives us a coordinate grid. Let's plot it. So -2, 1, 2, 3 here. Whoops, come on. And then we're going to call it A. B is 3, 1, 2, 3, 3, -3. And then C is -2, -3. C. All right, so here's our triangle. Guys, it's really hard to write on this tablet, so forgive me for my unstraight lines. Hopefully when you do this on your paper, you can see that this is a right angle. Anytime it's a right angle, we put that little box looking thing in. All right, so let's find the area first. That'll be pretty easy. So area first, 1/2 base times height. Okay, well now notice this is straight up and down, so we can simply count the boxes. Okay, so we can go 1, 2, 3, 4, 5, 6. So this side is 6. 1, 2, 3, 4, 5. Okay, so the base is 5 and the height is 6. So area equals 1/2, base is 5, height is 6. So 1/2 times 30, which is 15 units squared. Don't forget, we're talking about area, so we're in square units. Okay, so the area of this triangle is 15 units squared. Now, the horizontal and vertical lines were very easy to count. With that said, you cannot count diagonal lines. Okay, you can't do it. Your answer will be wrong every single time. So, how would we find the distance between A and B? Yes, we would use the distance formula. So we're going to use the distance formula. Remember, we learned that in last section. The distance formula, I'm going to write it up here. x2 minus x1 squared plus y2 minus y1 squared. Okay, now be careful because we have to know what 2 points we're finding the distance formula of. So you have to ask yourself, when we're going to perimeter, we know AC is 6. We know CB, which is 5. What we don't know is AB, right? That's what we need to find in order to get this perimeter. So we're going to use the coordinates A and B to find the distance between A and B. Okay, so let's label this, let's just do this 0.1 and 0.2. So this would be my x coordinate of 1, y coordinate of 1, x coordinate of 2, y coordinate of 2. All right, let me plug it in. All right, distance equals x2, which is 3, minus x1, which is -2 squared, plus y2 is -3, minus y1 is 3, and that is also squared. So let's simplify this, baby steps. So 3 minus a -2 is a 3 plus 2. -3 minus 3 is -6. Okay, so this is just 5 squared plus -6 squared. All right, 5 squared is 25. Be careful, okay? What is -6 in parentheses squared? That's -6 times a -6. This is a positive 36. A lot of kids mistake it as -36. Nothing squared is a negative, okay? Negative times a negative is a positive. So 25 plus 36 is what? Square root of 61, which is roughly, put that in your calculator, 7.8. Okay, so we know the area is 15, so this is 7.8. Okay, so now to find the perimeter, it will be 6 plus 5 plus 7.8, which is what? 11 plus 7.8, which is 18.8. And that's perimeter. Oops, that's an 18.8, not an 8.8. And that's just units. Not units squared, just units. All right, let's look at example 3. So we have this funky looking figure that's like, what shape is it? Oh my gosh. It's going to be very, very hard to find the area. We could probably find the perimeter, but it's going to be hard to find the area of this figure. So let's go ahead and do perimeter first. Now the nice thing about this is that these are all straight lines, so we can just count, guys. So 1, 2, so this is 3, 2, this is 2, this is 3. If I count all these, this is 13. 3, 1, 2, 3, 4. Guys, once again, all I'm doing is counting. This is 8. And 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Double check me, but I think it's 16. I counted 16 twice. And this is 6. So I believe that's the perimeter. Okay, that's everything around. So if I start, so I have 13, starting there and I'm going right. So 13 plus 3 plus 2 plus 2 plus this 3 plus 6 plus 16 plus 8 plus 4 plus 3, and then I'm back to 13 where I started. All right, so if I get my calculator and I plug all those numbers in, I get 60. So the perimeter is 16 units. Feet, centimeters, inches, we don't know. But 60 is the perimeter. All right, now let's look at the area. This might be kind of complicated because it's such a weird looking shape, but we can break these down into a bunch of triangles. So like here's a triangle up top. Here's a triangle here. Here's a triangle here. And then the big triangles at home. Big triangles down here on bottom. All right, so let's do this. The area of this rectangle at top, remember length times width? 3 times 13, so 3 is here, 13 across the top, and that is 39 units squared. Let's do the big one on bottom. This is what? 16 times 8. So here's your 8, and here's your 16, which is 128. So 128 units squared. This rectangle here, so here's 2 by 2, and this is a 1 by 2. So 1 by 2 is 2, 2 by 2 is 4. Okay, so the area then would be the 39 plus 128 plus 2 plus 4. And if I put that in my calculator, I get 173. So the area is 173 units squared.